Hey coders, welcome back. This is I think last day I missed uploading any video because it is getting tough, right? I mean, when you have work, you have to actually complete it, right? So yesterday I was not able to make any video. So today I was tired, but yeah, let's go one of these again. Sorry, and hopefully yeah, try to solve it. So maybe I'm not able to upload daily videos, so I might change my videos to be from day one, day two, day three to be more like assessment one, assessment two, and assessment three. And I will try to upload like two, three videos weekly because it is getting tough, right? When you spend like 8, 9 hours in the office and then come back and then spend, right, against the screen, it was very hard and it is very hard to be honest. Um, so yeah, I mean, I I actually feel very bad for the yesterday when I miss it, but sometimes things doesn't go as you think, right? I mean, that is what that is. So yeah, I'm really sorry for that. So like last day I promised, let's go today on on-site interview. So there might be like 3, 4 questions, and hopefully we will be able to tackle all of these. So let's see how it goes. So yeah, it says like you can get up to the 4 questions. You cannot pause the timer and all. So let's start. Let's see how many questions. Okay, so 3 questions we have, and I think the third one might be hard. I will not check that, but might be. I mean, I'm not sure about it, but I think two mediums and one hard, I guess. But yeah, let's try to solve all these three today. So let's see the first one. So we have an array of stones where stone I is the weight of the highest stone. Okay. We are playing a game with the stone. On each turn, we choose the heaviest two stones and smash them together. Suppose the heaviest two stones have a weight x and y, with x less than equals to y. The result of this smash is if x equals to y, both of them will be destroyed. Okay. And if they are not equals to y, the stone of the weight x is destroyed and the stone of weight y has a new weight of y minus x. Okay, okay, I think understandable. At the end of the game, there is at most one stone left. Return the weight of the last remaining stone. If there are no stone left, return zero. Okay, so I mean the question is saying you have to pick two heaviest, basically two numbers in this array that are the largest. So for example, here two largest numbers are 7 and 8, right? So and now if they both are equal, no? Like if they are like 7, 7, so both of the stones, both of the numbers will be removed from the array. And if they are not equal, so there will be new stone. So these two stones will be removed, like 7 and 8, and the stone with the value 1 will be added because 8 minus 7 is equals to 1, right? So this is what here it is, right? So here in the first time we are choosing like 7 and then 8. These are the two largest one, right? So we picked up them from this array, and then we're gonna do like they are not equal, right? So 8 minus 7, 1. So 1 will be added in the array. So like 2, 4, and then 1, 1, 1, right? So 2, 4, and 1, 1, 1. Okay. And then we have to keep doing this until we have only one stone. So this is the question. If you see the constraint is very, I would say, loose. It says like, and at max, these array may contains like 30 stones, right? So yeah, and stone eye is max value is like 1,000. So can we do just the brute force? I'm not sure. I mean, if we just have to do the brute force, what we will do? Okay, we can put these items into a priority queue maybe because we have to pick always to the largest value. So we put this into the max heap, right? So heap is something if you don't know, it's a data structure and the very it basically order the element in kind of like binary search tree, but not exactly. But it makes sure that the largest element is always at the top, and either you can make. min heap or max heap, right? So if you make the max heap out of all these numbers, so you can the top is the very first element will be 8 and the second element will be like 7. So what you just need to do is pick the two largest number, and if they are equal, very good. If they are not they equal, then we have to put the difference of these two values again into the heap. So I'm not able to think like, do we have any clean way to do it, or just like we have to do the brute force? And that is what I'm not sure. Um, so let's try with the brute force maybe, and let's see how it goes, and maybe we'll try to figure out if something goes wrong. Right. So yeah, let's try brute force. So I will let the length of the array. I'm gonna create a priority queue. Why? Because I just wanted to pick the two largest number again and again and again, right? So I can select priority queue maybe. And by default, Java priority queue is min heap, but we want max heap. So I can just say collection dot reverse the order, right? And then I'm gonna initially put all of these elements into my priority queue, right? Now, so with this property now, priority queue, we can just pick the two largest number from it and keep doing it until the priority queue size is not equals to one, right? So I can say while PQ dot size is not equals to one, and as per constant, now we will always be able to achieve um PQ with like size one. I'm guessing because otherwise it might run for very long. But I think this should work. Um, there is at most one stone left. If there are no stone left, return zero. Okay, okay. So while PQ that size, I can say something like greater than one. Right. So either it is zero or one. We have to stop. Now what we're gonna do is we're gonna pick the two largest ones. Let's call it like A maybe. PQ dot poll and then B. This is the second largest. Right. And then if A equals to B, well continue. Otherwise, you can say PQ dot offer math dot absolute A minus B. Why? Because we have to make sure we are taking the largest one first, like 8 minus 7, not 7 minus 8. It might be there. So this absolute will take care of the negative value. And now if PQ dot size equals to 0, we can just return 0. Otherwise, we can return PQ dot peak maybe, or poll you can use. Either you can, so we, with the peak method, we are just seeing it, and with the poll method, we are actually pulling out that element from the priority queue. So yeah, I mean, code-wise, it's very simple. I'm not sure, do we have to do any optimization in it? Um, yeah, but let's try running it to any compile time error. We don't have any. Let's try submitting it. Yeah, so it's I think 1 millisecond, so it's quite faster, right? So yeah, I think I'm pretty happy with this solution. I don't think any optimization is needed. Um, yeah, so for this one, you need to make sure you know your priority queue in whatever your programming language is, right? So we call priority queue or heap, maybe some people prefer calling it heap. So you have to know and its method, right? How you can add it, how you can pick it, how can you remove it. All these methods you should know, and try to understand the question. Like we have to pick always two largest ones. So the other thing you could do is maybe get this array, sort it, and then pick the last two one, right? And then again add that element, then sort it, then again. So that you can do that, but the main advantage of priority queue here is it will do the sorting for us. So it will be easier to write. So I hope this one is clear. Let's move to the second question. Oops. Yeah, I think this is the same. Um, what? Is it the same question? I think so. I think so. Why these are the same question? Last stone weight. Oh, okay, okay. This is last stone weight two. Okay, I'm not reading it. So, I mean, it says like we have a stone again with a weight. Okay. We are playing with the stone. On each turn, we choose any two stones smashed together. Suppose the stone have a weight x and y with x less than equals to y. The result will be the same that we did in the previous, right? At the end of the game, there is at most one stone left. Return the smallest weight of the left stone. If there are no stone left, return 0. Even the constraint I'm seeing I mean, what, what I'm missing? So here it says like 30 and 1000, okay? And here it is also 30 and 100. Okay, okay. So here you see it says like no, I don't know it is visible or not. It is not visible. Okay, I can maybe. Okay, I will write this constraint in the top, guys. So in the second question, we have something like this constraint. In the first question, the constraint was for stone of I, each element are like 1000 max to max. But for this one, it is like 100. So I think I can copy paste the same previous question. It should work. Let me copy this and let me paste it, and I will change this to A. I don't know why they have repeated. Am I missing something? Or let me try running it. Yeah, it should work. I mean, no, it is not. Okay. We have, but why this is not stone where stone is the yes, I'm in the second question, right? Yeah. So we have again stones with they have weight on it. We are playing a game with the stone. On each turn, we choose any two stone. Oh. So here it says like we choose the two heaviest stone. But here it says like we are playing a game with the stone. On each turn, we choose any two stone and smash them together. And suppose the weight x and y with x less than equals to y, the result is the same like previous. Now at the end of the game, there is at most one stone left. Return the smallest possible weight of the left stone. If there are no stone left, return 0. Okay, so it says return the smallest possible weight of the left stone. Okay. Yeah, this will not work. Obviously, I messed up. So I initially thought the question is same, and yeah, again, I think I told you guys in my earlier video, I have very bad reading comprehension. I have to uh, make it more better, but yeah. So we have to make sure. Okay. Let me explain you now what question is saying, and then maybe we'll try. So this is the array, and this is the. Okay, let me. So this is now. So in the initial, the very first question, what we did was we can choose any two the heaviest stone, and then we have to keep doing that operation. That's fine. But now in this question, what we have to do, we can choose any stone. Either we can choose one, or maybe seven, or maybe one and two, or maybe eight and four, and we have to keep doing it until we have one stone left. But the problem is we have to make sure the smallest weight of the left stone is there. So maybe we try to remove all the stone, and maybe we can get back one as an answer. If we cannot make one, maybe two as our answer. If we cannot make two, then four as our answer. Like minimum one we want, and we have to choose these in a greedy way, I can say. So let me zoom out. Yeah. So on seeing the constraint, I'm thinking about like dynamic programming or maybe greedy because it says like listing smallest possible weight. It's a minimization kind of problem. Whenever you do like minimization or maximization, we have only like three, four algos, right? So I am thinking of like binary search, the very first thing. The second thing I'm able to think is let me show you. Whenever I see, whenever like minimization and maximization, the very first thing I can think of is like binary search. Second is DP, third is greedy, and the fourth one is BFS. So these are the four algorithm I always try to categorize, and with solving so many questions, I am able to think like these are the only algo are there, right? So binary search can be there. I mean, why not? Because can we do using DP, but what will be our state? Um, I don't think DP. I think it is a binary search problem. So if you know binary search unanswered, I think I have like three, four questions on this topic. So why this is because whenever I see this optimization, no, I try to think about these four algo and try to understand like can I solve using binary search? Can I solve DP? Can I solve using greedy? Can you solve using BFS? Why binary search is clicking, but I'm not sure about it because we have to make sure the answer is the minimum, right? So maybe I will try to check one. Can I choose stones between these values 2, 7, 4, 8, and 1? And can I get my answer as a 1? Right. So maybe I will choose maybe some other number first, like 4. Right. So can I make my these numbers collide each other and can I get my last number as a 4? If I can get last number as a 4, maybe I should try with 3 or 2 or 1, something more lesser. Right. So this is what I'm thinking. If you don't know binary search on answer, I would say try reading some article about it. But I need to make sure to. I just need to read it one more time to. I mean, wanted to make sure it is a binary search because DP. I'm not seeing any um recursive way to do it because hmm. Mm, but the only problem is even though I choose any number as my answer, I will try to run and try to find what is the last number for it. And if it is a possible, then I will try to reduce my search space. So actually, I need this thing. I need this my solution from the previous one. Why? I will tell you. Let me copy paste it here. So this is the previous thing. Did previous time we did right? We were keep doing again and again and again, and then checking. So here I would what say na, I will check basically. I will check can I make my answer 10. So let's say my minimum smallest weight that I have left will be 10. I'm assuming that. And then I'm check here. So these logic will run for 10. Can I make 10? If I can make 10, I will try to reduce it. Maybe go with a 5. Can I make 5? If not, let's go between 5 and 10, maybe 7. Right. So this is the idea I'm thinking. Um, but again, I'm not 100% sure about it, but okay, okay, let's wait. So what can be the minimum in answer for this? Minimum can be zero, right? Maybe all stones get removed, so minimum can be zero. What is the maximum we can have? So maximum will be, I think, the largest number in this array. I think we can choose that. I don't think we can have answered anything greater than the largest element in this array. So let's do that. Array dot frame of a dot max. Do we have to do like get as int? Yeah, maybe the element doesn't exist, so I think this is it. And then I will typical our binary search. So this is the mid will be the thing that we will checking. Can I make my answer as this mid? Right. So I mean I will do something like um mm, maybe uh, wow, can I do that? Maybe I can write a function maybe. I don't know. Right. Okay, right minus left divided by 2, and then I will say if check mid, then I will, if if you're able to make that number as an answer, maybe we should try something lower. So that's the idea. And then I can check again, maybe return, um, um, check again with left if it is a possible left, otherwise left plus 1. Let's write this. I will explain this one more time. Just let me write it first in mid or maybe target, I can say, and I will call my answer like last tone weight, and I will pass this A. So I will also need to pass it here. I will also need to pass here, and um yeah, return um target is less than equals to x. Mm. Okay, so what I'm doing now? Okay, let me explain. So for this arena 274181, I need to make sure. So I am checking any number. Let's say I'm choosing level 7 maybe. Can I make all these numbers collide with each other and get 7 as my answer? But the only problem is they can choose any number. So which numbers to choose, that we have to use using greedy way. And I think this is good idea to choose the largest one, because in the last we only want answer to be the minimum. So I think this is fine. I think this is good. Right, let me see what we have failed last time. Okay, wrong answer button what? Do can I see the input? No. Okay, no worries. Um, yes, let's try for this one. Let's try for this one to see the. Let's run the code. Okay, we have an error. It says method check in the class cannot be applied to given type. Yeah, of course, because I have to pass A also. That's fine. Let's run it again. Okay, I'm getting 41. That's very bad actually. How am I getting 41? Oh, did I messed up here? Saying let's say my answer to be the 5. Oh, I just messed up the condition. I think I have to do greater than equals to x. It is giving me the largest number that we can make. So let me check again. I'm getting 9. That's not correct. Um, what needs to be done now? Now with this course, I think this is indeed the binary search, but at the end of the game, there is at most one stone left. Return the smallest possible weight of the left stone. So whatever value we are passing, if it is a less than greater than less than target, um, and here we are doing max here, and this is fine because last time we executed for the previous problem, so I don't think there will be any bug for this one. I'm checking for target. Can I make my A? Okay, but yeah, I think one problem here. I am choosing any number. Mm, Should I do DP? Because constraint is very small, very, very small. Maybe I can do that, but how will I, what to say, cache the value? Or should I just try with normal recursion? I don't think this will work. I think yeah, it will not work because here again we are just getting here the value will be always same. The last tone weight thing, no, it will not work. Mhm. No, binary search, it will not work. I think we have to go with dynamic programming, but how? Okay, let me think. So 2, 7, 4, 1, 8, 1. Now the question says now you can choose any two numbers. What does it mean? It means either I can choose 2 and 7, or maybe 2 with 4, or maybe 2 with 1, or 2 with 8, or 2 with 1 again. And then I do my recursive call for the remaining ones, and then keep doing it until only one element is there, and that will be my answer. Can I do that? Um, mm, but only problem is how I'm gonna cache the value. Because the constant, maybe I can use something like, but it is 40. But I can use maybe, okay. So stone that length is 30. Maybe something I can use as a bit mask for masking all these values. Mm, yeah, let me try something like dynamic programming. But how? Let me show you what I'm thinking. So I'm thinking now we're gonna choose all the pairs because now the question says you can choose any pair. So why not do the brute force, right? Choose any pairs like 2, 7, 2, 4, 2, 1, 2, 8, 2, 1, right? Then 7, 4, 7, 1, 7, 8, any two pairs, and then do the collision and put the numbers again. But how I'm gonna put that number again? That's the question. Because stone eye is like 100. Bucket, maybe I can put it into the bucket. But stone short length is the only cannot memorize if I use the P. I just use normal brute force. What with time complexity then? I'm gonna choose for each number and then I'm gonna repeat it again and again and again. And then, but the only thing I'm able if I apply dynamic programming, how I'm going to like what is the cache the value, the repeated ones. Or did I just do the brute force? Maybe, maybe. Uh, maybe just put DFS on A with now number of elements currently it has. So something like A dot length. Uh, okay, so And why? Okay, this is the DP problem. I can assure you now on this one. This is indeed a DP problem. And somehow it feels like a choose, non-choose, I mean, knapsack kind of problem, but I'm not sure. Because ultimately we have to choose these numbers such that the differences is minimum. Okay. Um, and if you put to this, I'm gonna like 2, 4, 7. I might choose like 2 in one group, 7 in somewhere, but I'm not sure. Okay, let's move the third question maybe. And then we try to come back and solve it. I'm not sure. But yeah, let's give us some time to process on this one. Let's try it with third question maybe. So we have to design a time-based key value data structure that can store multiple values for the same keys at different timestamp and return the key value at a certain timestamp. Okay, this is interesting. Design a time-based key value data structure that can store multiple values for the same keys at different timestamp. So we have this key, we have this timestamp, and we have to return the value based on key and timestamp, I would say, I think. Uh, Key value at a certain timestamp. Mm-hmm. Okay. 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 I think this is easy, I would say. Am I missing anything? Okay, so here the question says, no? You're gonna have your key. So the input will give me like key value and timestamp, and I have to store the value in such a way that I can retrieve that value using key stamp and timestamp. So maybe I can just make a new key out of this key and this timestamp. Will that work? Because same key and there will be no same timestamp, I'm guessing. Same key and a different timestamp. Yeah, I can just create maybe one new key out of this. I mean, I don't know why this question is tough then. There will be 2 into 10 to the power 5 calls, and that's fine. I mean, we can do it in constant time. So why not just use the hash map? Just create a new key out of this key and the timestamp. Will it create any problem? I don't think so. Yeah. So I mean, I'm thinking about something like this for this one. Map string, and I think we have a string as a value. Yep. And string as a value. Map new map. Maybe I should use this constructor. Map new hash map. And when I'm setting now, I'm gonna create a new key. Maybe it's just a new key equals to key plus maybe just a bar like this. And okay, I have to see what is the key and value length. It is like 100. Oh my god, this is too much just for a key. Maybe we can use some hash function for this one to hash it into something like more easier. Because you see, the key length can be 100, and 100 is like too much. I don't know HashMap will do this for me or not, but making a key size of 100 is like a overkill, and it will take time whenever we try to retrieve that thing. So do we have? I think we have to write some custom hash function for this one to basically convert this string of key and the timestamp into something unique key, right? For a string kind of problem, we can do how we can hash it. Hmm. Maybe I can just use normal get hash method. Um, so we gonna have to, yeah, we have to make this key plus timestamp using some new key which is efficient to store. And how we can do that? The key value consists of a lowercase English letters and digits, and timestamp is like 10 to the power 7. It is very huge. Key can contain multiple timestamps, that's fine. And maybe I can create multiple hash map, maybe map with a tree map. Uh, Not sure. Yeah, I think this that will work actually. So for each map, we're gonna have for each key, we're gonna have like um a tree map, and that tree map can have some time, and using that time, we can actually get the answer. Hmm. Yep. 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 Okay, so one thing note you to notice here, no, is the timestamp here. You see, the timestamp is an integer value. So we need some data structure that can basically find this thing. Let's say any value like 10 to the power 5, where it is the 10 to the power 5 in a like quick way, like in the constant time. And not constant, even logarithmic time will work. So either you can write their own custom method for it, or maybe I can use the simple tree map and data structure. So instead of just storing a string to string of string, I'm gonna store like tree map. So it will store the key value in a sorted order, right? Maybe integer and then in string. So this integer is for like the timestamp. So what I'm gonna do now, I will first fetch the value of the tree map for each of this key, and then for each of the timestamp I can extract the value out of this tree. So that's the idea. Yeah, I think that should work. That should work. So here now you see, I'm gonna say if maybe my map, or maybe map dot compute if absent, maybe map dot compute if absent, or I can just check normally. If map doesn't contains this key, contains key, I'm gonna say map dot put key comma new tree map. Oops, right. And then I can say simply like map dot get key dot add this timestamp and the value. I think this is very simple. So, okay, the crux, I think here's the timestamp. Timestamp is an integer, and we have to somehow find the value in a timestamp in a like logarithmic time. I think tree map provides. You can use your, I think we can even write our own binary search for this, but I think this will work. So I will explain this one in more detail. Just let me, I'm not, I think, yeah, this could work. I mean, initialize, return a value previously with this. Okay. 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 And now, whenever we try to get it, so maybe something like um var 3 equals to map dot get or default I'm doing because this key might not exist. So null maybe. And if 3 equals to null, then I can simply return empty string because we have to return something. Timestamps are quickly increasing. That's great because it will be sorted, right? So that's why it gives me hint of binary search, but I think I can use the tree map. We already have that lower and higher method in the tree map, so that should work. Yeah, I think so. So if it is a null, I'm just gonna return it. Otherwise, I'm gonna get my tree. No, we already have our tree. And then we're gonna do something like var f equals to this. Or I'm taking the floor of it in my tree map. So maybe like tree dot floor key, and then I can pass the timestamp. So the floor key method, if you let me explain quickly. So we have tree set and tree map, which are the sorted collections, you can say. So in the tree set, we have something called higher, lower, or floor or ceiling, meaning the numbers gonna be stored in sorted order like this. So let's first think for the tree set, and tree map is also very similar. So if this is sorted now, and whenever I will say like if we use like tree set, let me show you tree set um concrete class, this one. So whenever I see tree set dot lower on 6, let's say maybe I can remove this one to 2, not 2, 5, and this one to 7. Okay. So if I say like tree set dot lower 5, so this will give me 4 because the lowest number, just the lowest number which is just after this 4. So that is 4, right? So this is what lower to. We have something called floor. If we take the floor now, for 5, it will return me 5 because 5 is there. If floor of 6, 6 will give me 5 because 6 is not there, then it will return 5. So we have lower, floor, then we have ceiling, right? So same, if we store this into a key value thing, like in tree map with some value, maybe something like this, or something like this, or something like this. So I can do like tree set dot lower key or up lower sorry floor key ceiling key, and I can get the exact number, the position of it. And if I get the position, I can just return this value. So this is the idea for this one. Now, if this floor key doesn't exist, then we're gonna return nothing because as I discussed, na, the floor will return. If the number exists, it will return that. If does not exist, it will give me something that is lower, which we don't want, right? That's there. Now we can simply say like return tree dot get f. Um, so I think this is it for this one. Yeah, tree map. I think this is it. This is it for this one. I think this the timestamp you have to know. If it is an integer, then you have to how you gonna organize your hash map. That was the only problem in this one. So let's try running it. See any compile time error. Yes, we have. Map.get key. I know there will be no add method. There will be put method in the hash map. So let's try again. Okay, I'm getting this. Let me compare with null null bar bar null bar 2. Yeah, that's fine. Let's submit it. Yeah, we are able to. I think a little slow, maybe. I don't know. But I hope you get the idea. I think the questions, the timestamp is the main thing to notice. If it is an integer, then you have to store it in some way such that you are able to find it like in logarithmic or constant time. So even you can store this in a sort. The timestamp always gonna be comes in a sorted order. So maybe I can store these values in a list of array instead of here I'm doing like tree map, right? Maybe I can do something like list of integer, and I will keep adding it the timestamp and the value. And whenever I try to find out, I can do the binary search to get this timestamp, and then again we get this value. Yeah, I think this was good question. Let's now come back to our second question. Again, we have a stone, so we have to somehow brute force all these values such that the smallest possible weight of the left stone. If there are no stone left, return 0. So when we gonna have 0 as my answer. So for this one, when how I can make it like a 0? So the only way I can make this as a 0, if I can divide it, can I make this 0? No, I cannot make it. But let's say it is like um no, no, 8 to 10. I mean, when the answer will be 0? The answer will be 0 when we have something like 10 comma 10, right? So then answer will be our 0, and that is the minimum possible. Do we have any other way? Or maybe we have something like 10, 20, 20, and then 10. Then again I can choose this 20, 20, and then again I can choose the 2 and 2. So do we have to make pair in it such that um these things are become to 0? How I can make all of them 0? Maybe I can group two sure. So for example, if it is like this, no, no, let's try for this example maybe 2, 4, 2, 4, 4, and 2. Let's say this is my input. What is the minimum possible uh, weight we can left off for these ones? Um, 2, 4, 4, 2. So I just need to group it like this. So now the 4, 2 will give me 2, and this 4, 2 also give me 2, and then I can just return the 2 and 2, and then this will be 0. Okay, so I think we have to group it somehow. But how we gonna group it? Um, okay, maybe since we have to it is okay, it is now feels like a knapsack kind of problem. But again, how I think we have to do this like sum equals to sum by 2 or something like that. Um, okay. Smallest possible weight. I need to make sure. Okay, so when I can have answer like 1, the answer will be 1 when I have a number like 7 or 8 or maybe 10 or 11. Then my answer will this will give me answer as a 1. This will give me answer as my 1 because 7 8 are not same. So we take the difference and put it back into the array. So 8 minus 7 equals to 1. That's fine. I think we have to split it somehow that it gives me the best outcome. Okay. This 2 will go somewhere, then the 4 will go somewhere, and then maybe 1 will go somewhere. Not sure. Because now I'm 100% sure is like we have to do some kind of partitioning because we have these kinds of DP problems where we do like subset sum. Can we divide these array into a part into a sum such that their sum is like 0? I mean, can we divide this array into two parts such that the subset sums of these will be 0? Feels like that. Um, okay. So if I do 3, 7, 8. I will try to group it. Okay, maybe I have to make the group. What kind of group we can make? Maybe a group that is so the highest. Like can choose the numbers. Okay, x equal to y. Okay, I think we have to do the brute force, but how? So 7, 8 will be like this. Then I'm gonna maybe I can choose 2, and then I can choose something, then I can choose something, and I will keep doing it until we get sum, and we're gonna return that sum, and then we're gonna do like total of this array, and then total of this array. Best. Okay. Mm, mm. How I need to devise this array? So, okay. I think one thing to notice here is if I get this array sum, what will be that? That will be like 7 to 9, 9, 4, 13, 14, 22, and then 23. 23 by 2, it gives me nearly 11. So if I can make my sum 11, can I make it? Can I somehow make my sum 11? 8, 8, 2, and 1 using half of these elements maybe by choosing any two elements like um 8, 2, 2. Okay, if I can make this 11, when I make 8, I can choose 9, I can choose 2, these two 11. Mm, this it's tricky, I'm not able to. But I'm 100% sure now this is a kind of like a DP problem. And I'm also sure that this is a knapsack kind of problem because at last we just have to divide this array in an optimal way such that the difference is minimal. And now how I can make this sum as a minimum? Maybe what the best thing I can choose here. So if I choose something like 274, 8, answer is 1. So this one will be like the closest value we can get. So 0, 1, then 7, 2 will be 9. The closest value I can take is like 11. So basically I can make a group of 22. And what is the sum? 7 to 9, 9, 4. 13, 14, 22, 23. So 23 minus 22 is equals to 11 is equals to 1. Is this what it wants? Okay, I think this is more like a hit and trial. I mean, this is so bad. Let me show you. So one pattern I'm able to find out just because I have solved no knapsack kind of problem. You see here, the total sum for this array will be like 3, 4, 4, 6, 10, 11, and we have 1 as a carry, and then 3 to 5, 5, 3, 8, 8 to 10, 10 for 14, and then we have 1 carry, so it will be 151. Now, half of this 151 is equals to um 7 and 5, 75. So, what I will try to do, I will try to make, can I make my sum as 75 or anything that is closer to or less than 75? Why? Because that then I can divide this into two groups, maybe something like this, maybe group of maybe 7 or 8, something with difference only one. So two closest group how I can make. So maybe okay. I think this is it. This is it. So like one. I mean, I want to take some smaller example. Yeah, I think this will fine. This will fine. Okay. So here you see the total sum is 10, 14, 23. Fine. Now we have to make sure we wanted to achieve a group something like this. Something that their sum is like they are so close to each other. So how we can divide these two arrays such that their sum is as close as it could be. So that will be something like maybe I try to divide this array such that their sum they are equal. So maybe if it was instead of 1, it was 2, then the sum we get will be 24. And then we will try to make, can I make a group of 12? Because if I make the, if it is a possible to choose some number such that their sum is 12, then the remaining number sum is also be gonna be 12 and sum will always be 0. So I can just return the total sum minus whatever the best half value we are able to divide. I think this should work. Should work. Uh, so the idea is, let me, so first get the sum of this array. I can say array dot stream dot a dot sum, and then what we're gonna do is this is the required sum, maybe sum divided by 2, and let's try to find out the best closest sum, closest to rec maybe something like this. So this is what I'm trying to find using this my method. The, the closest sum we are able to find by choosing some elements in the array A such that the required is as close as sum by 2. So this is what I'm trying to find using best. So I'm called DFS. Start with a 0 and this is my current sum. This is my required. Let me show you how I'm gonna write this thing. So this is the starting array. This is my current sum. This is required. So here now, I'm trying to make two sum elements out of my this stone such that their sum is as close as it could be to sum by 2. Because if I'm able to find a sum that is equals to 0, I mean, if I able to find two subsets such that their sum is 0, I can just return that. I think that will be fine. So what I'm gonna do, I'm gonna choose some values. So let me show you how we can do that. Maybe the first thing is I will choose that value. So that will be like DFS A I plus 1 current sum plus A of I comma required. And I will make sure, I mean, can, and then I will not choose it. So let me put it here and not choose DFS A I plus 1. I will not choose like anything here, right? And we're gonna have some answer. Maybe I can just create an answer here, maybe best. Maybe like integer dot, what can be my best value? Min value, right? and this is like choose, and I can do like best is equals to math dot max of best comma choose, or maybe by not choosing best equal to math dot max of best not choose. I have to initialize this one also, something like this, and then I can return this best. Now we have to write bunch of conditions. If our current sum is greater than required, this is not we want. We want our sum to be as close as half of it. So if the my current sum is exceeded, I don't want that. So I can return the maybe max value, min value, right? Because ultimately we want the best answer. And if I equals to a dot length, then I can just return. Um, so for this one, when we are able to do this, we can just return the current sum. And we also have to memorize this thing. So yeah, we will do that. So this will what we'll do now. This will give me the best possible number that is closest to sum by 2. And then I can simply return like this. Return total, or maybe I have sum minus best into 2. I think that should work because of our theory. This should work. Uh, Arrays, same. Let's try compiling. I'm hoping for seeing some compile time error. No, we don't. Okay, that's fine. If I will submit it, now I will get the TLE. That's for sure. Let's try submitting it. It should get TLE. Yep, you see, I'm getting the TLE. Why? Because this is classical knapsack, and we can, if and even if you did see the numbers, the stone I value is less than equals to 100, so we can memorize this thing. The I, so what the things are changing in this met DFS method? You see the I is changing, going from I 0 is equal to 0 and to the length of this array, and this current sum is going from 0 to the max of required. So we can just create something like integer, and generally I call it memo, or maybe I can call it cache, and then I will initialize my cache here. Cache is equal to new integer, and length will be n plus 1, just n plus 1 just for extra safety, and the required plus 1. So these are the two things are changing in my DFS, and then I can just add it into my base case. If hash of I comma current sum is not equals to null, meaning this value is already calculated in some of our recursive method, then return the value from there. Don't go into again the DFS call, just return that from here, and just before returning the answer, just do like this. Just cache the value for current sum and then return it. And I think yeah, this should work. Let's see. Mm, output is 1 and 5, and this is what we want, right? So let's try submitting it. Okay, yeah, we are able to solve it. Okay, I just messed up. I mean, I must have realized this thing first. Like, we have to do the partition, honestly. The question, it is not so direct, but yeah. So I hope you might be confused from this one, but it is more like a feeling because I have solved this kind of question before and it just clicks, right? It's not like I haven't solved these kinds of question before. I'm solving this for the first time, and that's why it is. You might think like, okay, how you can achieve, how you can know about this one. But this stone thing, the stone problem, I think on LeetCode we have like 6 or 7 variations of the stone problem. So stone one, stone way 2, 3, 4, 5, 6, 7. I think 8 or 9 problems are there on this type. So yeah, I mean, we just have to do the partition. And the one thing you can get the hint is here it says uh, On each turn, so here you can choose any two stones, any. So you have to, and the what is this dynamic programming do? It basically checks for all these conditions, all those variations that we can think of. It will iterate over all of it, and then we just simply cast the value which are already calculated. So I should have focused more on this one, but yeah, it is good learning for me also. So yeah, I will not forget this question for life, at least for 1 2 year. I can assure you that. But yeah, I hope you like it. So yeah, these are the three questions for today. I think this one, I think it's very. I think this is stone one maybe, and then we have stone two, and then we have this. I think this one was easy for me, and yeah, I think I stuck on question number one and two. But I hope you like it. Let me know about this problem. So yeah, thank you so much for watching. I think we crossed like 1 hour maybe. Yeah, but yeah, thank you.